Correctly identifying your static turning tools in the tool data is crucial to your machining operations. Oftentimes, the step gets overlooked and can cause bad geometry on a part. On today's Mazak Minute, I will identify key ways you can avoid this error and maximize accuracy by properly inputting tool data. So grab your notepads, let's get started. Hi, welcome back to the Mazak Minute. I'm Mike Zillich, part of the HEH technical team. In today's Mazak Minute, we're going to talk about turning tools on the tool data page. Let's get started. The first off we need to do is identify how to have the correct tool, the correct hand of the tool. There are three different types of tools. You have a left hand, a right hand, and a neutral. If you look at your tool holder or the box that the tool holder came in, you'll notice on the example I have on the screen, you'll see a DCLNL. That last letter represents the hand of the tool. So in that case, you'll see a left hand, the middle one, you see a right hand, and finally, N being neutral. If you don't have the box or you can't read the tool holder itself, another method I like to do is grab a tool. And what I want you to do is hold it in the palm of your hand with the insert facing towards you. If you look at this tool, it is pointed to the right. It is a right-hand tool. So if I'm turning towards the main spindle, it's going to be in this direction. The next tool I have is a stick tool. Again, I'm going to hold that tool up, and the insert again is facing to the right, right-hand tool. And the last tool I'm going to show, if I hold the tool up, it is pointed towards the left side of me. That is a left-hand tool. So hopefully that helps you. If you look at it on the screen, you can see, looking down at the tool, the left is pointed, or the insert is pointed to the left. The middle, the insert is pointed to the right. And a neutral tool is in the middle of the tool itself. When you go to the Mazak control, what you're going to do is you're going to press the furthest most left arrow key. That's going to get you the main chapters. And what you'll do next is you'll see a soft key that says Tool Data. On the Tool Data screen, on the Smooth G control is what I got represented on the slide today, is on the left side you have the turret station numbers with the descriptions of the tools. You'll touch on the tool that you want to modify or edit, and on the right side you would see the tool information. We'll get into that on the next slide. To get to the edit of the screen, you're going to go on the Edit soft key, and then you're going to go to Tool Data Assign. From there, you're going to see the right side of the screen, and just breaking it up a little bit, what you'll see is that you see that the tool description, in this case it's a general, the part is on the outside turning, so it's out. The nominal size of the tool is basically the name of the tool. The tool set is the actual values off of the measured tool eye. The most important one that I was talking about earlier was the cut direction. It really is important that you have the correct hand of the tool and the spindle rotation. And we'll get into that in a little bit. Finally, you got nose radius, width of the tool, the cut angle, edge angle, and your wear comps and cycle times. So I went ahead and I numbered some of the different features, and let's take a look a little bit at what each one does for us. So number one is going to be the tool type. You're going to see that there's going to be general. General is used for OD turning, ID turning, and edge facing. You'll have groove, used for OD grooving, ID grooving, and edge tree panning. Threading, you can thread the outside, the inside, and sometimes people will put a phono finish on the front edge of the part. T-drill is going to be a drilling tool where the chuck rotates. T-tap is going to be tapping operation with the chuck rotating. And finally, you have a special tool. Special tool might be used for a bar stop, or sometimes people will use it as a bar puller. The soft key is what you'll see down below on the description at the bottom of the slide. You see how it looks on the screen. You got your general, groove, thread, T-drill, T-tap. You go to the number 2, you got the part. That identifies the direction the tool is facing the part. So you'll have out, in, edge, in, and it says inner back. And you see how on the down below on the soft keys, you'll see the magenta red as well as edge, edge back. So the magenta color is good for the second spindle. There's a diagram for support for input on our controls, and that helps describe the tools. Here you're seeing that if I look towards the right-hand side, an edge tool is a tool that is horizontal and it is facing down the face of the part. You go to an in, that's going to be your boring bar tool. Out is going to be your OD tool. And again, you have the on the left side, the descriptions in the magenta color. That's going to be the edge and the in. And again, that's used for your second spindle. Number 3, that's what you use to give your nominal size of your tool. Preference I like to do is for my turning tools, I'll use the included angle of the insert. So for a CNMG insert, I'll do 80. VNM or DNMG insert, I'll do 55, and VNMG for 35 degrees. If I got a grooving tool, I'll give it the width of the tool. So if I had a 120 tool, I would put in 0.12. Most importantly, if you had a drill, sometimes it's important that you put the actual size of the diameter of the tool in there, because it will be calculating the RPM later in the program from the surface feet. And I got ahead of myself there a little bit, so we're going to keep on regrouping here. So nominal, we got thread example. I normally use my included angle of my insert, typically 60 degrees. The T-drill, diameter size of the drill. This is used to calculate the RPM of the chuck from the SFM in the program. T-tap, you're going to type in the size of the tap, and that's going to be used to calculate the RPM of the chuck. In the next slide, what we're going to do is I'm going to show you how to enter in the size of the tap. And finally, like I said, a bar stop or a bar puller, you would refer to that as a special. Getting back to the tap, what I'm going to do here is an example for a 1/2" 13 tap. You'll see that you got the numerator, denominator, hyphen, pitch. So the first thing you're going to do is on your soft keys, I'm going to select the unified thread. And then on the soft keys, you have the denominator. So in our case, I have a 1/2". So I will highlight the 1/2" soft key. And then in my prompt box, I will type in 1-13. So that's 1/2 13. The next item on the tool data screen is number 4, which is the ID code. This is used if I have multiple tools with the same tool description. So I have the capability of the alphabet from A to Z. For a tandem holder, if I'm doing something on a main spindle, second spindle, a lot of times I'll use the A, so I identified the main spindle, and B for back for the second spindle. The tool sets, those are going to be the values that I will measure off of the tool eye, and they would be represented in the tool set X, tool set Z. Number 6, this is the important one that I keep on telling a lot of people about. The cut direction is the letter on the soft keys where it says right and left. That represents the hand of the tool. The arrow direction, the clockwise, counterclockwise, you see there's one of each for the right hand, one for both for the left hand. The clockwise, counterclockwise gives that the spindle direction. The next page is going to be a screenshot of our support for input, and this helps really define the right hand tool and the direction how it's cutting. So again, I'm going to come here and I'm going to grab my tool and I'm going to face it that let's say that the main spindle is over here on the right hand side. What you're seeing is as the tool is coming, you don't see the insert, and the chuck is spinning counterclockwise. If I grab a left-hand tool, this time you're seeing you are actually seeing the insert, and the insert is cutting towards the chuck. If you are turning back towards the tailstock or the second spindle, you can see that on the right side of the screen, a right-hand tool, you would see the insert, and on the left-hand tools, you would not see the insert. Number 7 on the tool data screen, you're seeing nose radius. This is where if you look at your box of inserts, a lot of times it's going to be the third number on the numbers. So if I had a 432 insert, that last number, number 2, is the number of 64ths that is on the insert. So basically, this was a 432. That's where you're seeing a 32nd typed in there. Number 8 is going to be the width of the tool. You're going to enter the width of the tip to the back edge of the holder. On the next page here, next screen, you're seeing that the width is all the way to the back edge. So a lot of times if you have, let's say, a 1-inch stick tool, from the tool vendors, it's pretty much standard that the distance from the front edge to the tip of the tool, it's a 1/4 inch. So that's where you're going to be adding a 1/4 to it, giving me 1 1/4 inches. The cut angle. This is going to be based on, for outside and inside tool descriptions, it's the angle from the horizontal line, the Z-axis, to the cutting edge in the cutting direction. For edge tools, it's going to be the angle from the vertical line to the cut edge in the cutting direction. If we take a look at the next page, what we're going to see is a picture that defines those items. So on the top of the screen, you'll see circled in the green is the cut angle. That's coming from the horizontal line. You're going to have 90 degrees. In most cases, a CNMG insert is going to have 5 degrees more clearance on the tool. Normally a 55 would be 90 plus 3 degrees, so I would put 93 in. On a boring bar tool, you're seeing that from the horizontal line to the cutting edge, you're going to have 90 plus, again, 3 or 5 degrees. Those degree angles, you'd have to look at your tool vendor catalog or on the internet and see those values. Number 10 is the edge angle. Okay, I just talked about that a little bit. The edge angle is going to be the included angle of the tool. So basically what we're going to do for a CNMG insert, it's going to be an 80 degree, DNMG 55, and a VNMG is going to be a 35. And now on the screen, this again is the support for input. You can see it is the included angle of the tool. The top is the out. The middle is the edge where the tool is horizontal facing the part. And then the bottom picture is a boring bar tool or an in. Number 11 is going to be your wear comps. There you can compensate the x-axis. The x-axis will be a diametral compensation. The z-axis and the y-axis are 1 for 1. And number 12 is a max wear. Sometimes people like to put a value in there so that in case an operator types in a number that's too large, that the control would flag it and not continue on the machining. Number 13 is going to be the tool holder type. Here you're going to enter in 1 through 4 or 0 for none. This holder description is used for chuck and tailstock barriers. Descriptions of each of the holders can be found in the individual machine specific operating manual. I do have a couple pictures of what they look like, but the soft keys, what you see there, is holder 1, 2, 3, 4, and holder none. For a 3-axis mill, what you're going to see is that the turning holder would be a number 1, boring bar holder, U-drill holder, or the horizontal milling head would be a number 2. The V-type, vertical type milling head, which would be drilling on the OD, would be a number 3. And finally, the facing holder, which would be the tools that you saw previously as an edge, those would be held in a number 4. If you had a 2-axis lathe, a lot of times you'll have a block that's internal to the turret, and it will have 3, I call them acorn screws that fasten the tool in. That would be a 0. If you have the tool where you can put an extension on the face of the turret, that would be a number 1, and that allows you to have the tool stick out a little bit more, giving you a little bit more room for interference. A number 2 will be your boring bar holder, your U-drill holder. And finally, a 3 will be your facing holder. Down below, you see that there's a section called Life. In Life, you can set the time in minutes that you want to use for tool life on that insert. A lot of times the tool vendors will give you speeds and feeds based on a 15-minute tool life. On the number 15, cut time, that's going to actually show us the actual minutes of the time. Once 15 is equal to or greater than the lifetime, it would flag it and say that the tool life is over. You can also as well do it based on the number of parts that you're machining. That would be number 16 and 17. 16 is going to be the life number, and that's going to be the maximum number of parts that you're going to machine per edge on the insert. 17 would be the counter for that, and it's going to count up the number of parts that you machine. Finally, down below on the material on 18, basically Mazatrol uses cutting conditions to calculate out speeds and feeds in the program. We're going to help identify what type of carbide, or if it's high speed, the material of the tool itself. For turning tools, you'll notice that it will have carbide L, coated L, interrupted, Cermet L, CBN L, For drilling tools, HSSD for high-speed drill, carbide drill, and insert drill. For tapping tools, you'll have tap and synchro. For ball mills, carbide B and Surmet B. And finally, for end mills, you'll have high-speed end mill, carbide end mill, insert end mill. So I'm going to take a couple of screenshots now. We're going to review individual tools by themselves. So the first one we're going to be looking at is the grooving tool. So looking at it, you have on the far right, you have an edge, and that would be like a tree pan tool. In is a grooving in an inside diameter, out, edge, and in. The cut direction is the same. You would hold that tool up in the palm of your hand and determine the hand of the tool. The nose radius would be the small corner radius on the edge of the groove tool. Then you have groove depth. There will be a max groove depth given by the tool vendor so that we don't get into the tool holder itself. And then tip width is what actually controls the actual size of the groove. A couple pictures from the support for help. You'll see again the direction of the tool. The top left, the right hand with the counterclockwise arrow. You're going to see that the graphic shows the insert shaded. That means it's upside down. If you look at the bottom towards the main spindle, you're seeing that it's going clockwise direction, and it's a brighter yellow where you do see the insert. Again, if you're turning towards the second spindle, the right hand would be visible, the left hand would be facing down. And then to the right, you're seeing the width of the holder, the groove depth, the tip width, and the nose radius. Notice the blue dot. That's the tool set measure where you're measuring the tool off the tool eye. Tool data screens for threading tools. I have an edge looking at the right side of the screen, thread in, out, edge highlighted for the back second spindle, and in highlighted in magenta for the ID thread second spindle. You'll have your tool sets. You have your cutting direction, your hand of the tool, the width. And if I go to the next page, again, you're going to see the description. The width is coming from the back edge of the tool to the tool tip. The edge is, again, the coming down the face of the part, in being the boring bar tool or the threading tool, ID thread, and the blue dot, again, represents where you're touching it off at. T-drill, you're going to be able to drill the main spindle with the edge on the right side, and if I'm on the second spindle, you see the edge highlighted in magenta. That would be on the second spindle. And if you look at the information on the left side, notice that instead of having the hand of the tool, the only thing that it's showing me is spindle rotation, clockwise or counterclockwise arc direction. You also will have an edge angle, which would be the included angle of the drill. A couple, the screenshot of the support for input, the nominal size, the edge angle, and again the rotation. The tool measure point will be the blue dot, the tip of the drill. The T-tap, just like the drill, you're seeing you're having an edge for the main spindle, and you're having the edge in a highlighted magenta color for the second spindle. Just like the drill, you're going to have spindle rotation, clockwise, counterclockwise. The tip of the tool you'll see as blue dot, the center of the tap. That is where you're touching off the tool, off of the tool eye. So in your operating manual, I grabbed a diagram here that helps identify the tools. You'll see the tools on the left are your main spindle, turning spindle 1. The right side is turning spindle number 2. And you'll see that you have your left, right for your out tools, your in, edge. It's a nice way to maybe put that piece of paper for the operators to help them identify the tools at the machine. Another screenshot I took out of the operating manual shows the position of the point where you'd be touching off the tools off of the tool eye. Tip of the insert for the most part. If you look down at the grooving tools, you can see that it's going to be facing the edge towards the main spindle. Threading tools, I typically use the far left edge and the tip of the tool. And finally, the T-drill, T-tap. It will be the center of the tool and the center of the tap. Thanks for watching. We hope you found the information useful. If you have questions or would like to submit a topic for future videos, leave it in the comments below. See you next time on the Mazak Minute.